Good afternoon, everyone. My name is Christy Ford. I'm the account executive at Online Resources and your moderator for today. A quick reminder to please turn on full screen mode for better viewing in the presentations. And if you have any questions, don't hesitate to type them in as we go. We are live here and would love to answer your questions along the way. And if we don't, we'll get to those at the end of the showcase today. We would like to welcome everyone to today's Lunchbox webinar. This is focused features of VXModel. We will be discussing Creaform's modeling software product today. Well, here with me today from Online Resources is JD Schomburg. He is our VP of Operations here at ORI. He's been with the company for the past 9 years and has been a part of 3D data collection for a total of 19 years. So welcome.
Thank you
for being here. We also have in the studio Cade Hill. Thanks for being with us, Cade. Cade is our Director of Engineering Services. He is our resident expert in reverse engineering and GD&T applications. He has been with us for the past 6 years and is a wealth of knowledge. So thanks for being here. We appreciate it.
Thanks for having me.
JD, do you want to take just a minute, share with everybody who we are here at ORI and what we do?
Sure. So I'm JD Schomburg from Online Resources. We started in 1991 as a manufacturing technologies company. And our main focus was to really look at different emerging technologies and prove them out for our manufacturing customers to make sure that when they implemented them, they could hit the ground running. So that started with CAD/CAM. And then in 1996, we jumped into 3D printing, 3D scanning. We were getting into reverse engineering. And then just after that, we jumped into inspection and quality control. And we now have lines in robotics, automation, virtual reality, augmented reality, web apps. So we really take 3D data and 3D technologies and simplify them for the different uses.
Great description of who we are. Well, let's jump right in. We've only got a short time today, so we've got a lot to cover. Let's start with what is VXModel?
Sure. Sorry, that's me. VXModel is a Creaform product. Creaform is the manufacturer of the handheld 3D scanners that we really utilize for all of our industrial applications. And they are the best on the market. And what they have done is taken the scanner with a little bit of reverse engineering application so that it could go into your CAD package. So what is VXModel? It is the plugin to Creaform software that when people say, well, I've scanned stuff, but then what do I do with it? Get VXModel, and then you can do something with it.
Awesome. Kate, do you have anything to add to that?
Yeah, you pretty much hit the nail on the head. VXModel kind of acts as almost a middleman, for lack of a better term, between the data collection and then the final reverse engineered product for manufacturing. So.
Awesome. I want to make sure I understand this correctly. This is not a standalone CAD package. However, it does let you seamlessly manipulate scan data and create entities that can be exported to a CAD software. Am I correct?
Yeah, basically. So it's not a fully featured CAD modeling software like you would have in many other, from scratch CAD model building softwares on the market. It's designed specifically for taking your scan data and giving you the reference features that you need to then build that model in those CAD modeling packages. A lot of third-party CAD modeling softwares do not handle high-density scan data very well. VXModel is engineered to handle that scan data, that dense point cloud or mesh data, and give you the CAD features or reference entities you need to then have sort of a lighter set of objects that you can use in those CAD modeling packages to do your, CAD modeling operations, surfaces resolution, extrusions, things like that.
So in general, when someone brings a scan data set in and they try and rotate it,
you can bring it in, but in general, it's kind of a
clunky.
Yeah, like a read-only type scenario. It's difficult to work with, clunky. VXModel is intended to speed up that process and make it very easy to create things you need to actually build the model. So
super cool. Mm-hmm. Well, let's just from your perspective, what are the top 3 benefits of VXModel?
Yeah, VXModel is a plugin that operates within the scan data acquisition environment. So you're not jumping from one software to the next to the next. The only jump that's required is from VX Elements, those reference entities bringing over into your CAD modeling package. Everything is self-contained within the VX Elements environment. So you finish scanning, you click a button, it jumps you right over into VXModel, all in the same software, and then you can create the things you need for the modeling. So there's no fuss. It's very easy just to quickly press a button, jump right over to VXModel, and start your modeling process with no effort.
Pretty seamless.
Yep. Additionally, the mesh editing capabilities within VXModel are second to none in the CAD modeling ecosystem. You can do things like smoothing your mesh and using like a virtual sandpaper on your mesh, deleting data, filling holes, cleaning your data using healing wizards and things like that. It's arguably the best tool in the market for direct mesh editing. And then third, it interfaces directly with a few different CAD software packages. So it supports, I think, 3, but it's able to export as generic CAD bodies to any software that's not supported in a direct transfer. So you can go to any CAD modeling package, but it's been developed so that it seamlessly integrates with a few specific ones.
That's awesome. Well, if you wouldn't mind, just take a few minutes and show us the software.
Yeah,
Sure. Go ahead.
And so while he's transitioning over there, I'll probably say it a few times, but some of the things that I think we really need to identify with Creaform, and that I'd like everybody to realize, is Creaform's ability to manage this raw data set of scan data and then process it into a very workable STL mesh is incredible. And that's really where I see their big strength. So I think that's something coming from that mindset. That's really why we're choosing VXModel in this very seamless workflow.
You can go directly from your scan into VXModel. This particular demonstration, I don't have anything that I've scanned right now, so I don't have anything in VX Elements, but I can just import an existing STL into VXModel, which I will do now. Go ahead and browse for that. Okay, so here we are. I've brought my scan into VXModel here. Very simple cast part. The first thing that we're going to want to do, as with every reverse engineering procedure, we're going to get this aligned to the origin. As with many handheld scanning procedures, the part's going to come in with no logical orientation relative to the origin. It's going to be floating out here in space. So let's fix that now. What I need to do first is create some entities on the scan that I can use to define what axes I'm going to align to which features on the part. So up here, we have some entity creation tools. I'm going to start by creating a couple of planes and then find an average plane down the center of the part. So when you create an entity in VXModel, you click on it and it brings up a menu that looks like this. There are several options here. You can construct things using other things, draw a line on a screen, for example. The most used one is this one here, where you can best fit these entities to the mesh. So holding the control key, I simply click on the surface that I want to use for this plane, and it extends that selection using the similar normal tool here to all of the triangles that have a similar normal direction. You can also see that it has provided me with a color map illustrating where this plane deviates from the scan. So everywhere in blue, the scan is shy of the plane. Everywhere in red, the scan is proud of the plane. So this is just a nice best fit plane to the side of the part. I'll go ahead and accept that plane there. And I'll create a plane on the opposite side as well. And then I will strike an average between those two using the construction method. I'll call this an average plane, and I'll select the two planes that I just created to find average plane on the part. I'll then rinse and repeat that same process on the planes which define this opening here.
I think one of the things I want to let people know is if you have questions, this is live. So ask those questions, answer. We'll see those pop up. If we want to try and show a feature that you're interested in, we'll make sure that we'll get to that.
Yeah.
Okay, so I'm going to put a cylinder on the ID of this now. And now I want to create a circle as the intersection between this plane and this cylinder here. And that circle is going to define my origin. Create a constructed circle here, a plane and cylinder intersection. Plane will be plane 6, which is the average plane inside of that opening. You can see I have a circle there. See that everything I'm creating also has this list of characteristics. You can review what you're creating as you wish when you're creating them. Okay, so now I have all of the entities that I need for alignment. So I'll go ahead and align this part now. Clicking manual alignment now. This menu allows me to choose what features I want to use to define what axes on the part or on the origin. So for my circle, I'll go ahead and grab circle 1 here. I want to define origin XYZ as the center point of that circle. For the plane number 3, which is the average plane down the center of the part, I will call this plane XZ. And then for the plane that's in the center of this little slot opening here, I will call this plane XY. And as you can see, my part is now aligned to the origin. Actually, let me flip these here and make this better. And I'll click OK. Now my part is aligned to the origin. At this point, I can do whatever I want with the mesh and know that all the operations that I'm going to be performing will be right where I want them to be. So I'll start just by hiding these entities for a moment. Like I mentioned before in Christy's last question, VXModel has a very robust suite of mesh editing tools. One of the most used ones is this sandpaper here. Think of this as just a digital sandpaper. So I'm going to increase my brush size slightly. Holding the control key, I can kind of paint away any of these imperfections on the part. And you can see how this sandpaper tool raises the valleys and lowers the peaks and allows me to make this nice and smooth backside. You'll be able to really see it here. Smooth this out. In addition to that, we have some other mesh editing tools as well. Let me make a copy of this here really quickly. That way I know that I'm not going to damage the original part. I'll just work on a copy.
And I know we're going through things.
Okay.
We're going through things really quick here. Again, this is some pretty robust software, so we're trying to show a lot. Again, feel free to ask questions.
Right. For example, if I wanted to make the as cast version of this part and remove some of these holes, what I can do is I can make a selection, something like this, something like this. I will delete these cylindrical surfaces, and then I can fill these openings back in using tangent patches. And here I am simulating what the part may have looked like in its as cast state prior to any of the holes being drilled in the part. So it's little mesh editing things like that. There's an entire suite here. We don't have nearly enough time to go through all of them, but those are some examples of the things you can do to directly edit the mesh inside of VXModel. To finish, I'm going to go ahead and create my last few entities here that I need for CAD modeling. So I have either side of the part. I have the ID of this whole location. I've got the opening here defined, the height of that opening. Let's go ahead and get the overall profile of the part. I'm going to create a cross section here, and I'll output this as a polyline to use as a construction entity in my third-party software. And the initial plane will be plane 3. And as you can see, it's struck a cross section down the center of the part. Maybe that'd be easier to see if I off here. Down the center of the part here. that. I also want to create the OD of this cylinder here, so let's do that very quickly. You are not limited to the surface curvature of the scan. As you can see, I'm best fitting the cylinder to the scan, but you can also apply your own constraints as well. Say if I wanted to make the axis of this cylinder match that, the axis of the cylinder on the ID, I can do that and apply constraints to these features I'm creating to make sure everything's nice and parallel and perpendicular where they need to be, on center where they need to be, etc. So I've created all the entities that I need to model this successfully in a third-party software. We're not going to go over that today, but I do have a pre-baked CAD model here that I'll go ahead and bring in. So let's pretend that I've sent this to VXModel, or excuse me, to SolidWorks, and I've done my modeling in SolidWorks or Solid Edge or what have you. Once I'm finished with that modeling, I can import that back into VXModel as reference.
Hey, Cade, before we go forward out of here, just there was a question that came up. The question is, does the smooth feature affect the overall size or shape of a part?
Yeah, it definitely affects the shape. If you go crazy and use it too much, obviously you're raising peaks and lowering valleys. You're definitely changing the surface characteristics of the scan, but that's not always a bad thing. Yes,
And is that the same for pretty much all of the mesh editing tools?
Yes, yeah. Okay. Any mesh editing you do is taking your scan further away from its true to life representation. But in many cases, that's what you want. You're trying to make a part that's to design intent rather than what it actually is. So as you can see, I brought in my CAD model here. I'm not aligned quite like I need to be, so let me modify this alignment.
Is this a pretty easy learning curve for people?
Yeah, it's easy. I
Okay.
think I can get somebody up and running in the software in like a day or so.
So, Cade, as you're showing the alignment structures and how that works, I want to talk a little bit about online resources and the value that we bring. So, if you are struggling with something and you can't figure it out, our support team is here to help you. Pick up the phone, give us a call, and we can get you through that struggle. That's a value we bring, and that's really what we're here for.
If you're spending more than 10 minutes, call us.
Yeah, I definitely say that. Don't waste your day. We're here to support you and get you through those hurdles. So yeah, if you're hitting your head against a wall for more than 10 minutes, pick up the phone and give us a call.
So I've got this correctly aligned now to my CAD model. What I'll go ahead and do is do a comparison to the bracket here. Let's say we want to hold a 5,000. A little bit more descriptive, maybe 20. And here we can see where the scan deviates from the CAD model that we created. This is a good tool inside of VXModel to go back and check your work and make sure that things are what they need to be. I can annotate this if I want, just by clicking. And rotate this around, maybe move these annotations somewhere where they're right as a
So this is just a very rough inspection process in.
Yeah, well, you want to be able to, when you deliver the finished product to your customer, you want to be able to demonstrate to them how
sanity check.
Yeah, how that model compares to the original, and just verify with them that the model is what they want, and say, okay, you know, I made a best fit plane on the right-hand side of this part. You can see that the part actually has a small sink mark here and is proud around the edges. So in the casting process, you have the material has sunk down in the center and still raised on the edges here. But we put a best fit plane across that. You can see we're slightly shy in some parts in the center and slightly proud in some parts of the edges. If we wanted to instead, if the customer said, you know, I want to have the part represent the maximum outer boundary of this side of the part, we could apply a max fit to that plane instead. Yeah. And have it sitting as if you had taken a plane and just set it down on the side of the part, touching off on the furthest point.
So you did a profile to get that general casting shape.
Mm.
Is it possible to do, I know the VXModel software does an auto surface tool that's very
Yes.
nice.
Yeah.
Can we do an auto surface, pull that CAD surface, will it come in as a solid that you can then
Yes.
do your CAD modeling processes, so with the other entities? The
Yeah.
cutting process, booleans, all that.
Yeah, right. You could bring in a CAD. You can bring in an auto surface into any CAD. An auto surface basically. I can just show you what it is actually. So I have my scan selected here. I'll just go ahead and click an auto surface. This should actually any of these floating.
Well, I think one of the big questions as we finish up here today, thank you for that, Kate. That was awesome. I think it's a really powerful tool to use. I think the big question is what file formats. That's where a lot of people are going to be curious. How do we get things out of here into usable data in our current CAD package?
Yeah, when you use the live transfer tools out of VXModel, the entities just come into SolidWorks or Solid Edge or Inventor, then you're able to just save. But if you're exporting,
what is an SLR? Whatever you
SLDPRT
just
is like, well, I shouldn't say that. Like any native,
native file format.
Yeah, like an SLDPRT is a native file format whenever you click the save button.
Okay.
And then Inventor, I think. But if you're exporting generic CAD entities out of VXModel, it supports all the standards. Step, Parasolid, I believe Parasolid as well. Okay. Do DXF, like if you do a cross section, you can export it as a DXF too.
So all of these software, or the software you see today, that is something that we sell. We sell the Creaform line of scanners. We've been using them since 2006. So we do see them as the top of the line systems for industrial applications. And this VXModel is just a seamless plugin. So that's why we wanted to shed a little light on it today, because we think people would be pretty excited to see how well that transfers into their scanning workflow.
Hey, thank you so much for sharing that. It's a great start for those who are interested in utilizing scan data for reverse engineering.
Yeah.
We really appreciate that. Well, we do have one kind of question that actually it's more my question.
Sure.
I'm just wondering, is the workflow still going to be the same kind of what you showed today, or is there a standard workflow? Or because everything seems so seamless that I'm wondering how that works for you as the engineer.
Yeah, that's a good question.
Well, I mean, as with anything, there's best practices that are good to follow, but it's pretty plastic in terms of being able to jump back and forth between VXModel and VX Elements. If you go to VXModel and you don't like what you see, if there's some noise on your scan or you're missing some data, you can just jump right back over to VX Elements, touch those areas up with the scanner, go back over to VXModel, and then you can jump back and forth pretty easily between the two plugins. So in general, yeah, just like anything, there are some best practices which we can go over at another day. But yeah, in general, there is no specific set rigid workflow that has to be followed to a T. You kind of have free range to work as you wish between the two softwares.
Awesome. That's incredible.
And we sell the software, we sell the hardware. We also have a full team here to help support. So we often say if someone is trying to get over a small hurdle, if it takes more than 10 minutes of your time, stop what you're doing, give us a call, because we can typically solve a problem faster than that for you. So that's really what we're here to do. And that's what we see our value add is really partnering with people instead of just like giving a product and saying, here you go.
Right.
Yeah. What a great support team we have. And it's awesome to be a part of that. So, well, unfortunately, that is all the time that we have today. If your question did not get answered, I have recorded it and one of our experts will be in touch with you the next day or two. Thank you all for joining us today for the Lunchbox webinar. Thank you, Kate, for your expertise and your presentation. We
Thanks for having me.
appreciate that. As always, if you have additional questions, don't hesitate to give us a call. That number is 765-482-9700, or you can contact me directly via email. That is at Christy, Kristy, @onlineresourcesinc.com. Again, thank you all for being here and have a great afternoon.